Hey, welcome back to Mr. P. Also with Precal. This is Unit 5, Topic 2, Lesson number 8. We're going to be finding equations when given certain points using matrices. So when you're looking at this first one, we're really just going to talk about what kind of equation this happens to be. So we have 3 points given. We want to find out what kind of polynomial is this. So just pretend that this is on a graph. So negative 1, 5, negative 1, 1, 2, 3, 4, 5 would be about right there. And 2, negative 1 would be about right there. And 3, 13, okay, that's going to be off. 6, 7, 8, 9, 10, 11, 12, 13. So it's going to be way up here. So the only way we're going to have well, if we had a cubic, keep in mind cubics look like this. There's no way it's going to hit all 3 of those points. Because it's going to go from down here, you can't hit this point, or you can just hit these 2 points, but it's not going to hit this point. So we're going to need something that's going to be more like this. So more than likely this is going to be squared or to the 4th power or 6th power. It's going to be some sort of even function. So it's got to have an even number as its degree. So we're just going to leave it at that. So it has to have an even degree. So this will have to be some sort of quadratic or quartic in that case. Now there is 3 points here given. We should be able to find a quadratic that hits that point, but this is actually not the vertex. So the way to draw it is actually more like this. And the reason I know this is not the vertex is because I've already gone through it and you can already see. So if you write it x minus 2 squared minus 1, then it's not actually going to hit these 2 points. So actually the vertex is slightly to the left of that point, a little bit lower, of course. Okay, but getting to the main focus of this lesson is about using matrix to find the equation. So this is another quadratic, and this one should work because we're going to use our trick of using matrices. Keep in mind for each one of these points, this is an x and this is a y. So what I'm going to do is I'm going to plug this x into this standard format of a quadratic equation, and I'm going to write it as an equation, one simple equation, and do the same thing for all 3 points, and therefore giving me a system of equations I can solve with the matrices. So if I put negative 1 in for x, that would be a times negative 1 squared plus b times negative 1 plus c equals the y, which happens to be 3. Now if I simplify that, so negative 1 squared is 1, so that's 1a plus, or minus, in fact, minus 1b, because negative 1 times b is negative b, plus c equals 3. Okay, I'm going to change colors. I'm going to do the next one. This time I'm going to put 1 in for x and negative 3 in for y, or f of x, which is your y. So that's a times 1 squared plus b times 1 plus c equals negative 3. Simplify that. 1 squared is still 1, so that's 1a plus b plus c equals negative 3. All right, one more, changing colors again. So that would be a times 2 squared plus b times 2 plus c equals 0. Okay, so 2 squared is 4, so that gives me 4a plus 2b plus c equals 0. Now, I've got 3 equations, and we can list that out as a system of equations. So this would be 1 for A, negative 1 for B, 1 for C. And then this one's going to be 1 for A, 1 for B, 1 for C. And then this one's going to be 4 for A, 2 for B, and 1 for C. And then we're going to call this matrix A and then matrix B. So this multiplied by A, B, and C should equal our solution, which is our constants, which is 3, negative 3, and 0. And this is very similar to what we did in one of the last previous lessons. Then I can now put this into my matrix, put this into my matrix, and it should work because this is a 3 by 3, and this is a 3 by 1, and the fact that this 3 and this 3 are the same means it should work. Even though I'm going to use the inverse of this, but the inverse of this is also a 3 by 3. So this should work. Now this trick won't work if you don't have enough points. You should always have one more point than you have a degree. So if this is cubic, then you would need 4 points in order to prove that it's what that equation is. So just keep that in mind. Now I'm going to pause the video because entering this in for A and this in for B can take a little bit of time. Okay, so I've got everything entered in, and I'm going to show you my screen, although it's inverted, I know, because it's a rear-facing camera. So I did inverse of A times B equals, and then I got an answer of 2, -3, and -2. Now, so that means that that's A, and that's B, and that's C. So now I can simply write my equation. I know these take quite a bit of time and a little bit of work, which is the reason why I'm only going to do a couple of them. Obviously, nobody was ever going to assign you 10 of these. That would take quite a long time. So 2 is A, so that's 2x squared minus 3x minus 2. Now, I can check myself if I put that in for my y equals, which I'm going to do right now. So 2x squared minus 3x minus 2. And then if I go to table, I should be able to find all three of these points. And -1, 3 is there, 1, -3 is there, and 2, 0 is there. So I have just checked my work. This equation is correct. All three of these points are on that quadratic equation. All right. Next question. So this one's a squared, so we have 2 points. All right, so now if you were paying attention to that last question, you'll notice that we have an issue here. We only have 2 points, and we have squared, which means in order to do the same trick that we did on the last one, that trick's only going to work if we have one more point than we have the highest degree. So we actually needed 3 points in order for this to work, but that doesn't mean we can't solve it. There is another way of doing it. In fact, this way I'm about to show you now would work either way. So if you prefer this way I'm about to do it, then this might be the way you want to keep doing it because it can always work. I'm really going to do kind of the exact same thing. I'm going to put this in for x and this in the y. You won't really notice any different until the very end when I put it in the calculator. So I'm going to put this in for x. So that's a times -1 squared plus b times -1 plus c equals -4. And then simplify that. That's +1, so just a minus, I keep doing that, so minus b, -1 times b is negative, plus c equals -4. Change colors, do the same thing for the other equation. That's x, that's y. So a times 1 squared plus b times 1 plus c equals -2. 1 squared is 1, so that's just a plus b plus c equals -2. Now I can turn this into a matrix. So this is going to be 1, -1, 1, but then I'm going to put the constant in the same one. So I'm going to have an augmented matrix, as we talked about in the last video, because if I just have a 2 by 3 and a 2 by 1, it actually doesn't work because on the inside you have 3 and 2. So as we've talked about in previous videos, that would not work, that other method of doing it. So then I'm going to do the same thing for the second line. So that's going to be 1, 1, 1, -2. Okay, so there is a way of doing this with an augmented matrix. So I'm going to enter this matrix in first. And I think actually I already put it in. So second matrix, I go to edit, I put in 2 by 4 and I enter this in. Okay, so now here's the trick. So then to solve it, because obviously we don't have 2 matrices, so you can't do the inverse of the first times the second one. So what we're going to do instead is go to your calculator where it says matrix, but go to the middle one where it says math, and then scroll down, and hopefully you have a new version of this where you have on B, you have reduced row echelon form, or let me just show you, there it is, reduced row echelon form. So you're going to click on that one for B, which is going to look like this. It's going to say RREF, and then put in matrix A, press enter, and it should give you something like this. It should basically give you the identity matrix, but in this case, since it's 3, so you'll see like 1, 0, 1 and 0, 1, 0, but whatever is the last line, which happens to be -3 and 1, and those are your A and B's. So when you have, so the answer ended up being, when you did reduced row echelon form, you get 1, 0, 1. This is 0, 1, 0. That'll always happen. And then your last answers, there's your A and there's your B of your answer. There is no C for this one. So the answer is -3x squared plus 1x. Now, double check that by going into your y equals, put this equation in, -3x squared plus x, and then go to your table and see if these 2 points are on your table, and they are, so then this method does work. All right, I'm going to do one more of these questions, and you can read this if you want to, but basically we're going to do the exact same thing, only we're going to have 1, 2, 3, 4 points, which means it's going to be cubed in this case. So I'm going to go through it exactly the same way. I'm going to put 1 in for x, so that's a times 1 cubed plus b times 1 squared plus c times 1 plus d equals 3. So that turns into just a, that turns into just b, that turns into just c, plus d equals 3. All right, so I changed colors, and I'm going to do the same thing for the next one. As a matter of fact, I'm going to pause it because I know I'm limited on time, and I'm going to come back once I've done the other 3 points. Okay, as promised, I've done all the work for the other 3 points, so the next thing I need to do is then turn it into my augmented matrix. And then now you can see why using the augmented matrix as opposed to 2 matrix actually was kind of important in that last video. So the first one's going to be 1, 1, 1. So that's A, B, C, D, and the constant. And then the next one's going to be 8, 4, 2, 1, 5. And then the next one's going to be 64, 16, 4. Now obviously we have a bigger numbers here, so they're going to, the reason why is because we had a bigger x, and you have a bigger x and you're being cubed, it's going to be a bigger number. So this is going to be 2, 16, 36. So be careful so you can differentiate between the 2 numbers. Leave enough space in between, and voila. Okay, so once again, I'm going to pause the video again, and I'm going to put this into my calculator. All right, so I've put this in my graphing calculator as a 4 by 5 matrix. And then I went to my graphing calculator and I did the reduced row echelon form, and then I put in matrix A, which is what I made this. And maybe I made a mistake, maybe I need to double check my work, but you probably got the same thing I did. You probably got, the ones going down diagonal. You got basically the identity matrix for multiplication, but then on the far right hand side I'm getting decimals. So I'm not really happy about what the answer is in this case, but we got to go with what I got. So I probably should double check my work just to make sure, but let's see if you got the same thing as me. I got 0.175 x cubed, and then minus 1.22. I bet that's repeated, x squared, and then plus 4.45 x, and then minus 0.4. Now, I'm pretty sure this is going to be hard to double check myself, because if I put this in the y equals and then I go to the table, I know that at least one of these is going to be rounded or it's going to be repeating, and unfortunately it's going to be kind of hard for me to check myself on this rather than just going back and checking my work. Let me know in the comment section if you got the same thing as me, or if maybe I just entered one of these. If you just enter one of these numbers in incorrectly, then that's going to throw everything off, and maybe I did that. I'm sure some of you will let me know. All right, thanks again. But the important part was the process. So if I helped you learn how to do that little shortcut and you think that's helpful, then please give me a like. And if you haven't done so already, please subscribe and have a wonderful day. Thanks again for watching. Bye-bye.